This video will focus on more practice with dimensional analysis. So first we need to take a few moments to actually make sure we understand what dimensional analysis is. Dimensional analysis is a very useful method for converting between units, which is why it's also named unit conversion or unit analysis, as well as the name of dimensional analysis. We use dimensional analysis, whether we are conscious of this or not, in our everyday lives, such as with time, so converting between hours, minutes, seconds, on travels, so thinking about budgeting for gas for a particular trip, knowing how much gas costs, what your tank holds, how many miles you're traveling, and then other budgeting as well, thinking about how many days you plan on staying at a particular place, the cost for food, the cost for lodging, etc. And then also baking, so converting between, say, tablespoons and milliliters, etc. Two academic areas that are often used with dimensional analysis are math and science, and we are going to focus on the area of nursing or healthcare professions, particularly unit conversion with medications. And throughout the video, I'm going to not embarrass myself too much. Instead of trying to pronounce particular medications, I'm just going to refer to it as the medication. So there are two particular techniques that I'm going to cover for using dimensional analysis. And so the first one is where you're going to start on the left. And that is where you're going to first identify what are you trying to find. And once you identify what you're trying to find, you're going to use a fraction with that particular unit, making sure that it is in the numerator or the top. You'll also have to take some time to figure out what conversions do you need so that when you multiply through by 1, your units are canceling so that you end with the unit that you're actually trying to find. As you multiply, you also want to simplify and then write the number appropriately. We'll talk about that a little bit more. The second technique is where you start on the right, and this is more used in nursing, and we'll focus in on that in a little bit. So starting on the right, you ask yourself, same as the other technique, what do you need? So once you identify what you need, you write that on the right-hand side of your equation. So you're really focusing on the end of your answer. On the left-hand side of your equation, you're going to start with what is your order. So this is, again, very focused with nursing students or healthcare professionals of, say, receiving an order from a physician. So what is your order? What conversions do you need? And that might be one conversion or multiple conversions. So dimensional analysis is very helpful for keeping yourself organized. Simplify your expression. And so you're going to set up your fractions so that all of your units cancel except for what you're trying to find. And remember, that's what we started with by asking, what do I need? And then write the number appropriately. For nursing professionals, you need to make sure that you always use a leading 0 and never a trailing 0. We'll discuss this more specifically in a moment. We're going to use a quick example of using both techniques so that you can understand technique 1 versus technique 2. So the situation is a doctor orders 50 milligrams of this medication. You, as a nurse or healthcare professional, only have 25 milligram tablets. So you need to determine how many tablets are needed. So technique one is start on the left. Starting on the left, we need to answer the question of how many tablets are needed. So what we know is that one tablet is equivalent to 25 milligrams. And so that's a fraction that actually represents a quantity of one, let's say, because one tablet is equal to 25 milligrams. And remember, tablet is what we're trying to find. So that is in the numerator. The next thing we're going to do is we're going to use other information to keep the tablet, but we need to get rid of the milligrams. So what we know is that 50 milligrams is equivalent to one dose, or the order that we were given. So we can use this and write it as a fraction to multiply through to eliminate the milligrams. Now notice in our original fraction of one tablet over 25 milligrams, the milligrams is in the denominator. So that means we need to multiply by 50 milligrams per that one dose, and making sure that the 50 milligrams is in the numerator. So we have one tablet per 25 milligrams times 50 milligrams per one dose. Notice we have milligrams from the first fraction in the denominator, but milligrams in the second fraction in the numerator, which will then cancel, which means 50 divided by 25 tells us we need 2 tablets for this one dose. Now, the other way to come up with the same conclusion is we're going to start on the right, which means what do we need to do in order to figure out the number of tablets needed per dose? So we start with the order. The order is 50 milligrams for one dose. So 50 milligrams divided by one dose. And then we need to convert milligrams to tablets. And we know that one tablet is equivalent to 25 milligrams. We want to again make sure that the units we do not want, which in this case is milligrams, are canceling. So 50 milligrams divided by one dose needs to be multiplied by one tablet divided by 25 milligrams. The milligrams will cancel. 50 is now being divided by 25, which gives us the same result as before. 2 tablets are needed per dose. Technique 1, I want to allow you to see another example where we are again going to start from the left. The situation here is we're going to convert 36 hours to seconds. So we are starting with the situation of 36 hours, but what we want is to end with seconds. So our conversions that we need to know that 60 seconds is equivalent to 1 minute. Now there's 2 different ways to write this as a fraction. 60 seconds divided by 1 minute, or 1 minute divided by 60 seconds. We'll figure out which we need in a moment. We also need the conversion that 60 minutes is equivalent to 1 hour. And similarly, we need to figure out if we need 60 minutes divided by 1 hour, or 1 hour divided by 60 minutes. With technique number 1, we're going to set up a fraction with the unit we are trying to find in our numerator. So in this case, we're trying to find seconds. So we want to start with seconds, and we want that in the numerator. So that means we're going to use 60 seconds divided by 1 minute. Notice seconds is in the numerator. We're now going to multiply by 1 with the goal of keeping the seconds, but getting rid of the minutes. So we need to multiply by 60 seconds over 1 hour. Notice minute is in the denominator of the first fraction, but numerator of the second fraction, therefore those units will cancel. Now, the next thing we have to recognize is we're not just talking about 1 hour. You were asked to convert 36 hours into seconds. So we need to make sure we recognize our last step will be to multiply by 36 hours times, divided by our one situation. Notice again, the minutes cancel, the hours will cancel, and we're left with seconds for this one situation. The only numbers in the denominator are 1 for each denominator, so we simply have to multiply across. So 60 times 60 times 36, which gives us our final answer that 36 hours is equivalent to 129,600 seconds. Technique number 2 is where we're going to start from the right. So our situation is that a doctor orders 0.5 milligrams of morphine every 4 hours. You have a vial of this medication, which is labeled as 2 milligrams per milliliters, and you are asked to determine how many milliliters are needed per dose. Using technique number 2, we're going to start from the right, and that lets us understand we are trying to find the number of milliliters. So what conversions do I need in order to end up with an answer of milliliters? What is our order? Our order is 0.5 milligrams per one dose. So we need to multiply in order to reduce to milliliters only. The conversions we need to go from milligrams to milliliters is that our vial is labeled that 2 milligrams is equal to 1 milliliter. So we need to decide, are we going to multiply by 1 milliliter divided by 2 milligrams, or 2 milligrams divided by 1 milliliter? If we go back to our order and what we're trying to find, our order is in terms of milligrams, but we're trying to find our dosage in milliliters. We need to get rid of the milligrams, which means our conversion has to have milligrams in the denominator, so it will cancel, leaving us with milliliters. So we will multiply by 1 milliliter divided by 2 milligrams. Notice the milligrams will cancel, and we only have 0.5 times 1 in our numerator, and then 1 times 2 in the denominator. So that is essentially 0.5 divided by 2, which means that this patient needs to receive 0.25 milliliters. Now, this is answered properly. It has a leading 0, which is needed. Why is that needed? Think about without the 0. Without the 0, it would be 0.25 milliliters, and that little point can be very easily misread or missed, and it could be read as 25 milliliters, resulting in serious injury or death of the patient, and that is something we would not want to happen, of course. One more example, and this will be our final example before you do some practice problems on your own. So our last example, the situation is a doctor orders 0.125 milligrams of a medication per dose. The vial is labeled, and we have to be very careful here. Notice it's labeled as 500 micrograms per 2 milliliters. And you are asked to determine how many milliliters are needed per dose. Starting with what we're trying to find. We're trying to find the number of milliliters. The order that we're given is 0.125 milligrams per 1 dose. And we need to determine what we need to multiply by in order to cancel our milligrams and end up with milliliters. The conversions we need to go from micrograms to milligrams and micrograms to milliliters. So we should know micro, we have 1,000 micrograms equal to 1 milligram. And the order is given as 500 micrograms per 2 milliliters. And again, the focus is on the milliliters. Starting with our order, we're going to multiply through to kill all of the units that we do not need. So 0.125 milligrams per 1 dose, we're going to multiply by the 1,000 micrograms per 1 milligram. Notice the milligrams will then cancel. But we need to convert to milliliters, so we need to use the label from the vial, which is 2 milliliters is equivalent to 500 micrograms. Notice there the micrograms will cancel. And so multiplying through, we have 0.125 times 1,000 times 2, and then this will all be divided by 500. And writing this appropriately, this simplifies to 0.5 milliliters per dose for this medication.